Now let's get back to the important aspect is the database design and how I'm partitioning the data into that. What are the partitioning strategy, partition key? That is a very important part of the system design. Okay, so we have talked about the high level storage high level system. Let's talk about what are the entities that we will be having. So once one of these we will be having a user table. Other we can have a, you know, we can have a conversation. We may have a some conversation settings, and we may also have the conversation user settings. I'll just okay. So user will have, you know, user ID, and it will have some basic metadata of the user. Let's say user ID or phone number, or his last login, created time,
Name.
yeah, name, or let's say email ID as well. Yeah. So these are the users table later, and we can keep the user ID here as a partition key, right? Or you can call it as a primary key as well also. So using the user ID, we will partition the data. The Let's talk about next the conversation table first. Okay, so conversation table is where your conversation is being message is being stored. So let's say there is a ID, conversation ID. Okay, then there can be the message ID, then there can be the text text, and then there can be the what else, conversation
Sender
ID,
ID,
huh?
maybe.
Or
Sender,
type.
who is the sender of the message.
Exactly, sender ID we can have, and we can have a type of message. Right, is a media, is a text, or is it a like in a, and the other message is like if I'm adding a somebody into the groups or some notification, all of those can be part of as a message only, right? You are adding somebody into the group and there's a notification sent to them that you are invited into this group. That could also be the
Hmm.
one of the as a part of a message only, but the type will be some the type would be like in a adding person to the group, or but there will not be any text, right?
Okay.
So uh, uh,
Created at.
yeah, and this is like a so conversation created at, and we can have a parent ID as well also. You may ask me why
What
the
is
parent
parent ID?
parent message ID. Let's say if I there's a functionality of in the WhatsApp that you can reply on the some particular message,
Right. Okay.
right? So that is where the new when you reply on the debt, that is a new message, but it will give you flexibility to get back to that particular message. That's so using the parent message ID, I can reach to that particular message which I have replied to, right? So the parent message ID can help me to achieve that functionality, right? Now so here let's just talk about that what is a partition key I'm going to choose. So the partition key for me is the conversation ID here. This is going to be my partition key, uh, right? So conversation ID is nothing but the is going to be static. Once let's say one group has a one conversation ID, we are talking one on one, it will have a separate own conversation IDs, right? So it's like a thread ID, you can say. in case of a Gmail, we have a notion like, you have a thread going on, you keep on replying on the
Right.
same thread. Similarly here, this is a conversation ID on which that you've been replying the typing and messages, right? So think of like that. So conversation ID is that, and then there's a message ID. So message ID you can think of like a counter, integer counter, right? And this Alex, this could be my clustering key. Clustering key. So message ID is my clustering key. It will help me to sort the messages, or let's clustering key sort by, yeah,
Timestamp.
a message ID itself only. Message ID will be an integer counter,
Okay.
right? So message ID is nothing but the 1 2 3 4. It will be an integer counter, and it will maintain that, given the conversation, message which started first will have a conversation ID, let's say 1. The next message will have a conversation message ID, sorry, message ID 2. Next message will have a message ID 3. So as in like, increment counter for with respect to given conversation, right? And there's a reason I've chosen the message this way, so that I can achieve much more functionalities if I keep the message ID as a clustering key and a sorted ascending order manner, right? So the later is the message come, the later is that it will have the longest message ID, right? And the text will have
Okay.
the text messages. Sender ID will have the sender user ID, you can say, or you can call it a sender user ID as well also, right? And let's yeah, and the type of the message, it could be a text message, media messages, or operations like adding into the group, calling, or some notifications, or you can call it a notification, media, text, notifications. And the created at what point of the time this message is created. And this could the parent message ID can be empty if in case you are not replying to the existing messages in the same conversation, right? So the parent message ID for those messages can be empty. Now let's just see. Uh, okay, so uh, so conversation user setting. Here I will having the conversation ID again. It will be a same conversation ID, right? And given the conversation, I will be having here the last message ID read. Okay, and give me a moment. Uh, okay, so given this conversation, I just wanted to ensure what is the last message that the user has read to. Okay, we'll need a user ID as well here. Okay, yeah. So yeah, conversation user setting, the conversation ID, user ID, and the last message ID it has read with respect to that conversation. Now the partition key here, it would be given this conversation, I think the partition key will be the given this user, it will come and ask, okay, given this user and this
Yeah, it should be
conversation.
user ID, right? Because every time a user gets logs into WhatsApp, he should be able to see the all the conversations and the last message thread of all the conversations.
Right. So let's just me think of it. What could be other way? What could be other ways of defining the partition key here? Just what do you think?
Like, if we keep conversation ID as partition, then for each conversation ID, I have to go and check which all users are there, and then go into get the last message thread of them. But here the use case is whenever user gets into logs into WhatsApp, he should be able to see all the conversations he has, and the after the how many messages have come after the last message he has read. That's why it would be ideal to place all the conversations is part of at one place, right?
Yeah. Okay. So here, yes, you made the nice point. So it should be the user ID as a conversation ID. Oh, sorry, user ID should be the my partition key here.
Partition key,
So
right,
yeah. So given a user, and then there is a uh, conversation ID. So user ID would be my partition key here, and
right,
this would be conversation ID would be my clustering key
right.
or
Here we can
sort key,
solve. Right, that's
right?
right.
And then this is my data. Okay, so now let's just define the conversation settings as well also, and then we'll also talk about how I am achieving all of my functionalities like the message ordering and all. That is important.
Okay.
So conversation ID, and it will have a last message ID. Okay.
Why this?
In this conversation, what was the last message ID?
Okay, so that we can see the last message out in the WhatsApp itself instead of before going into the conversation. Is that the use case here?
That can be also one of the use case. What was the last message? But we can also derive other use case. Let's say somebody has not have seen the last 10 messages, so uh, I should be able to determine, okay, this user, this conversation, it has read the 10th message, but there is a 20th message has come, so I can show
Okay,
them on a counter, 10 plus. So without opening
right,
that, I can show the 10 plus over there, right? And I can
right.
also
Got it.
sort them out, whichever the latest also. So to achieve that functionality, I would need this message ID. What was the last message ID it read it, or what was the message ID, last message that has been sent into that conversation, right? And then we can have a members. This is the list of members, right? Now, yes. So if in case of a group, every user has their last message ID could be a different, but with respect to that conversation, we have the what is the last message that has been sent to that, right? And who all are the member of that conversation, right? So uh, when
Should
the
we
group,
also be storing which who sent the last message?
I think that also always a part of a conversation, right? Given the message ID, a conversation ID, I can always find from the conversation itself who sent that last message,
Right, 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 right. Got it.
right? Right? But if it is a very, I mean, frequently accessed data, we may not fetch it from the conversation always. We may keep it into the conversation setting as well, the sender ID. But if it is not a frequently accessed data, let's keep it, organically the data, like in conversation. We may fetch join from the conversation and conversation setting and figure it out who is the sender basis on the requirement, right? Okay, so now the message, let's say client one has sent the message to the client two. Yes. The first time the chat server will create that message into the conversation table, the conversation ID. There's a message ID. It may create the message ID, and there is a text and the who has sent it, and it will create an entry into the conversation, and then it will update into the conversation setting. This is the one of the last message, right? And yes, that, so these are the two tables that it will update to at that point of a time, and that the it will send to the Kafka, the CDC pattern, the CDC connector will send to the Kafka fan out service, will receive that message. Fan out service will talk to the group service. Group service will ask that conversation ID. will ask to that conversation who all are the member of that conversation, and who all are the member of that conversation, and then all the members will be fetched, and fan out service will try to send them in the batches, you can say, or in parallel. It may connect to the request handlers and will try to send the message to the all of the members who are connected at that point of the time, right? Now, uh, so this is clear. So we have spoken about database schema, and here here the conversation setting will always have a one entry only with respect to given conversation. But conversation will have a number of entries. It's like in a append order mode, but in this case we will we supposed to update given this conversation. So this will be my partition key here only. That's it. Given this conversation, I wanted to, I mean, I just update the last message ID, right? And what all the members are there. So I mean, because I have to just keep the one, what is the last message ID, that's it, right?
So we are using 4 DB here, 4 DB tables, right? User
Right,
conversation, user setting, conversation. All are all of them key value stores, or are we
right. All
using
of them are the
columnar?
all of them are the
Sh-
NoSQL key value storage.
NoSQL is fine, but are all of them key value store, or can we use conversation as columnar database because we are having threads kind of structure there
So this
in conversation?
if when you say columnar databases, Cassandra is a wide column oriented columnar databases. So
Okay,
the NoSQL, but it is nothing but you can model the data as a key value in the Cassandra, or you can model the data in a columnar way as well. Also, it's just very minute difference if you understand those differences, right? How the data is being organized in the Cassandra. We can keep that separate session for the how the data is being structured in the Cassandra,
sure.
how we can model as a key value versus that columnar way, right?
Sure.
Uh, okay, so this is the now let's just okay. I'll just want to talk about actually when I gave an Uber interview, there was a question asked to me if the client has a very bad internet connection, right? Bad internet connection at that point of the time, fan out service supposed to send a message. It might be possible it may deliver that out of sync messages, right? Probably message id 1 couldn't be sent because the connection was very bad, and the message id 2 is being received. So how we ensure that the user experience is not bad here? I don't want to show the users having a inconsistent or out of order messages, because it will be a bad user experience. So that is where I have used the message IDs. It will help me to solve that problem. So what okay, hello guys, welcome back. So we'll continue our DB design where we left. Okay, so uh, we'll talk about the we were talking about the database design, and let's just talk about we completed the database design in our previous session. We'll continue how we can solve our queries, different WhatsApp requirement using the database design, and using these tables and all, right? So uh, I mean, we were having a user table, that is fine. So conversation user setting table is one of the important table. Like here we are keeping the pointer which message ID, the which of the message this particular user for that particular conversation it has read so far, right? So let's say now I wanted to ensure key this user the message uh, okay, so this user has we were talking about the delivery kind of things, when the message is being delivered and the message is being read, so how we will give those information back to the user, right? So what we can do, we can basically implement, we can obviously, okay, whichever is the last message that particular user has read it so far for that conversation, we have the last message id of that. Using that, if that there is a message id that he has read, let's say the message id is 123, so it means we can give that, in content, I mean, can give that idea over that front end side, that this is a, we can mark the blue tick with respect to that particular message id, right? Similarly, let's say we wanted to implement the feature like, uh, the delivery. So let's say the client one has sent the message to the client two, right? And the message has been delivered, but to the user, but we'll have to record it at the database side as well also, so that tomorrow, if we wanted to fetch and then see which message is being delivered and which message has been read, we should be able to give that consistent experience to the user. So what we can do, whenever the message is being delivered to the to the client 2, or to that particular user, we can update, here, last message id delivered, right? So it might be possible ki within that conversation, we have 10 messages starting from 1 2 3 4 5 6 7. The last message id was 3, but last message id delivered is 5, right? And once he read that fifth message, so the last message id read will equals to be a 5, and the last message id will also be delivered to 5. But it's like in a pointers, you think of it like in a pointers being getting updated, and so that we can give that an experience or intention to the WhatsApp client, saying, okay, these are the two takes. How we are able to give that, what all message it has read, with respect to that conversation. So every user who let's say connect to the first time to the WhatsApp server, it should be able to pull from the chat server, okay, given that user id, given me and given the conversation id, uh, what message I have read so far. So WhatsApp should be able to, figure it out which message it has to show as the two ticks, and which has message has to show the two tick along with the blue color, right? Basis on these last message id pointers, right? So that's how we can do that. And uh, so I think we can support those kind of a feature using these conversation table. Now let's just talk about, let's just talk about you fetching the top conversation. So conversations, uh, so we are having, when we open a WhatsApp, what we see the whoever has the latest message sent to us, right? That conversation window appeared to the top, and all are being ordered accordingly in the descending order of a time. Whoever has sent the latest, that window will appear first, and then the next sent. And we also see the number of the messages that has been unread so far, or number of the message that has been sent to us that we have not opened it, right? So how we can we can calculate those things using the two things. One is the conversation settings. So conversation settings, given the given the conversation id, we know what the last message it has been sent to into that conversation. So whoever has that person who has been talking into the chat thread or group thread, who must have sent the messages, and when he has sent the messages, the chat server would have updated into the conversation setting ki this is the last message that is being generated, right? And their corresponding message id, and that should be the incremental message id sequence number. Now conversation user settings and conversation settings, we can actually determine, uh, so basically using the last message id it has read with respect to that conversation. So let's say he has read that last conversation message id 5, and uh, the last message id that has been sent into that conversation is a message id 10. So using that, we can determine, okay, this conversation, there's a 5 unread message so far, right? We can compute that, and then we can give that presentation something like that over the WhatsApp key 5 plus, right? We see that, tip as a 5 plus, something like that. So we can derive using this, as well as there will be an n number of a conversation that user is being part of, right? What we'll do, we will we will only compute whose last message IDs or last message ID read with respect to conversation user setting is not same. So only those conversation will picked up, and then we will all of those conversation and whoever has been latest, and then we just give that delivered to the user side. Okay, this is the first conversation, this is the second conversation, and these many number of messages are unread into that, right? I hope
So one question here, like we are using message ID as a incrementing counter, right?
right with
So
respect to that conversation. Yeah,
each conversation will be having a different counters, right? Like message
right,
ID is with respect to conversation. That's how we
right,
are getting the
right,
count.
right.
Okay, it's not the global one.
No, we can't do that global one because given that conversation, it's local to the conversation. So
All right.
different conversation have their own different counter, but it is attached to that with respect to that conversation,
Okay, got it.
right? Now, okay, so then that's fine. Okay, now do you have any questions or anything specific? Okay, there's a one more thing that I have missed it here that we can keep it here is that media URL. Okay, so that so basically if that message is being in that conversation, that particular message has a mass text as well as some media URL, so we should be able to keep that metadata of that where that media is being saved to, right? So while being fetching those messages on the WhatsApp, we should be able to fetch the message uh, text as well as the media URL from that particular S3 location, right? Now, let's just talk about, so do you see that, I mean, when we go over the particular conversation, we just, uh, एक minute. Okay, so I mean, we have spoke about so far what are the different requirements, that we can support using our these following tables, and mind it that schema design is very important, how you place these the message IDs and all to support your feature. And if you are not being able to design the schema properly, probably you will not be able to scale your design. So keep that in mind. Database schema design and partitioning strategy is a very important key when while you're designing the system, right? So let's just talk about the important thing that when we go over the WhatsApp, we go over the one particular chat thread, right? We just scroll and then we keep on seeing other messages, right? How does it that happen? So basically, this is like in a time series data. Time series data is nothing but kind of a data that is being coming over the period of frequent interval of a time, like every t1 t2 second there's a something is being happening. So this is a kind of a time series data, you can say. And to support this kind of a time series data modeling, the conversation table we are modeling as a time series data, and is and we are using a NoSQL Cassandra database, as well as we can use a DynamoDB database as well. Also we can model our time series for the conversation in both of that databases. The model, how you model is matter when you're is not the database that matters while you're designing, but how you model it. But that modeling has to be supported through the sum of the database only. Like time series modeling can only be supported on the NoSQL databases, not supported easily on the SQL databases, because the data is being stored there is a very uh, different form versus the data being stored into the NoSQL databases, because LLM storage engines append the data into the end, and this is what we need here. Like in a WhatsApp message that is being coming, you just keep on appending into the end, and then you can just fetch all of the messages in one single shot, right? So when we are okay, when we go to the conversation table, one particular conversation, how we'll gonna fetch all of the messages? So we'll, given that conversation ID, right? Given that conversation ID, we would partition that using the conversation ID will go to the one particular instance of the databases, and using the consistent hashing will go to that particular partition, and within that particular partition we will see that the message being ordered as in they have come, right? And this message ID is a sort key here, right? So what we can do, we just keep on fetching the messages from there. Okay, the last message ID would have been 1000, then 999, then 998, something like that. It must have been in that decreasing order. What we'll have to do, as in the user scrolls, you keep on fetching all of the messages in a single shot. But this is more performant, right? Because in the single seek, when I say single seek, within the single call, you can able to fetch 1,000 of the messages, right? That is a very beauty of the time series data model, which is would not been possible with the SQL databases, because you cannot you'll have to entirely scan all of the data and filter out and then give back to the user, because that is the database is using the B plus tree structure. The node is being the entire DB disk is being converted into the pages of 4 kb, which is distributed on the different sectors of the disk, which is, so that is where the seek IO time would have been very high, and we can't afford that. Hence we need a something like an LSM based storage, time series kind of in a database, where we can fetch given that conversation and given that partition, entire set of the data. Now in the single seek, we make process 1,000, we can fetch 1,000 messages at a single call, right? And that is very efficient. Hence we need a something like an a NoSQL or time series kind of a data modeling for these kind of a purpose, because of our requirement is something like that. Because we now you can model this kind of a thing, time series data thing, wherever you have been having the chat threads, right? You can just think, because if you have to scale your system, you don't want the very high IO latency. You want very low IO latencies, right? You can always increase the read time by bringing that cache and all, but you can never increase the write time, because write means happening on the databases. You can never increase the write time until unless you have chosen the appropriate databases, right? So keep that a thumb rule in the mind. You can always increase the latency by bringing the cache and all for the frequent access data, but you can never increase the write time on the databases. So we'll have to choose very carefully what database should work for our particular use case. And I have chosen NoSQL databases here, which is DynamoDB either or Cassandra database. Both support time series modeling, and that should suffice our purpose, right? Now, so I've okay. Uh, I think we are done with the database design. If you guys folks have any further questions, feel free to comment on this YouTube video, and as well as reach out to me if you want to discuss any of the hot topic of the system design. Okay. Now we'll come back, for the API design of the same WhatsApp. What are the important APIs that we will be having, and we'll discuss in the next session. Okay. Thank you, guys.